Assalamualaikum and good day. My name is Nur Atira binti Ismail and my metric number is B0920100091. Today, I want to share about the introduction of our assignment. In this assignment, we will assign to find an actual structure. 3 topics are involved, which are stress, strain, and mechanical properties of material. Every component in a linear motion system experience some form of loading to apply force or motion. The component's reaction to these loads are described by its mechanical properties. Stress is the force applied to a material divided by the material cross-sectional area. Next, strain is the deformation of displacement of material that results from an applied stress.
The main objective of this assignment is to draw detailed FBD from actual structure-related problem. Develop equilibrium equation from the FBD drawn. Analyze force members from the structure. And lastly, find safety factor of the structure.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khalil Iqbal Isa. My metric number is B0920100124. So now next I would like to present about my conclusion, which is the first one is free-body diagram for the swing playground structure. So as you can see, the swing has 2 poles, which is A and B. So we has 2 support at the y-axis and 2 support at the x-axis, which is AX, AY, BS and BY. So you can see we assume that mass is equal to 60 kg. So we calculate the weight, just multiply with gravity, we got 588.6 Newton. So the total length of the swing bar is 1.5 meter. So in the center of the weight, we divide to 2 parts, which is 0.75 meter. So next, for equation of equilibrium EOE, we use sum Fx equal to 0. We got AX equal to BS. So next we use sum Fy equal to 0, and we got the first equation, which is W equal to Fay plus Fey. So next we use sum moment at A equal to 0. We got Fby equal to 264.3 Newton. So we substitute from the first one equation. We got Fay equal to 294.3 Newton. So we conclude that the Fay and Fab is the same Newton. So next, for the analysis and mechanical response, we divide to 4 sections for the swing playground. So the first one is we need to find the shear force and the bending moment. So at the first point, first section, we got 294.3 Newton for the first section, and the bending moment we got 110.26 Newton meter. So the last section, we got the shear force is 294.3 Newton, and the bending moment is 0 Newton meter, which is the moment need to be 0 to equilibrium the structure. So for the diagram, we got the shear force diagram and the bending moment diagram. So as you can see here, the maximum shear force is 294.3 Newton, and the minimum shear force is -2 -94.3 newtons. So for the bending moment, we got the maximum bending moment, which is 220.93 centimeter. So next, for the maximum allowable force for the system and factor safety in this structure. So we use a stress equal to FA, and we got the stress allow, which is 104087.33 Newton per meter square, or PA. So thus the max allowable stress is equal to 104087.33 PA. So next, we need to calculate the factor safety, which is Fs. Fs equal to stress ultimate divided to stress allowable. So the stress ultimate that we use for the stainless steel, which is 510 megapascal. So we need to divide to our allowable stress, which is 104087.30 pascal. So we got the factor safety is 4899.70. So we can conclude the value of the factor safety is greater than 1. So the potential of failure is low. So our structure is very equilibrium. So that's all for me. Thank you. And I will pass the present to our next presenter.
My name is Norada binti Muhammad Rizalmi. My metric number is B0920103995. So for today, I will discuss the outcome that we get from our group assignment. So for this assignment, firstly, from the calculation, we can see that we assume the parameters of the structure, where the height of the swing from the ground is 3 meters, while the width of the swing is 1.5 meters. A weight of 588.5 newtons is assumed on the center of the swing. So with all of these assumptions, we can determine the reaction force acted on the structure by solving equation of equilibrium. After solving the equation of equilibrium, we get the reaction forces are equal on the both sides, which is FAY and FBY, which is the value is 294.3 newton. After we get the reaction force for this structure, we construct the shear stress diagram and the bending moment diagram. Before we construct the bending moment and shear force diagram, we need to obtain the value for the shear force B and the moment M. To get the value for the shear force, which is B, we use the formula for equation of equilibrium, which is the total of F1. But for the bending moment diagram, we will use the formula for moment. For the next one, after we get the value for the shear force B and the moment M, we can construct the shear force diagram first. For the shear force diagram, after we construct the diagram, we can see the shear increases from 0 to maximum volume of shear till point FAY and keep constant till it reaches point W. At point W, the shear decreases and remains constant till it reaches the end point, which is point FBY, before the shear line increases back to 0. So this shape of that we get for the shear force diagram, you can see it caused by the reaction force acted on it. Between the point FAY and point W, there are no load applied, so the shear line will remain constant. While at point W, the load of W, which is the 588 newtons, is applied to the structure, cause the shear line to decrease till negative. As you see on the diagram, it till negative 294.3, and the line will remain constant till it reaches the end point at the point FBY. at the point FBY, another reaction force is at on this point and increase back the shear, thus the line is back to 0. So for the next one, for bending Bmma diagram, the moment is linearly increasing to first point of 110.36 Nm and it continues increase to the next point, which is 220.73 Nm. For the first half of this diagram, the moment increased linearly because the horizontal constant shear line on the shear force diagram. Next, the moment decreased linearly until it reached 0. This is also caused by the horizontal constant shear line on shear force diagram. Time the state of this structure is in equilibrium, the shear force diagram and the bending Bmma diagram will start at 0 and end at 0 too. For the last one, for this assignment, we also calculated the maximum allowable force of this swing playground structure and the safety factors of this structure. So, for this maximum allowable force obtained from this structure is 10.41 kilopascal, while the safety factor of this structure, we get the value of 4,899.7, where the value of the safety factor is greater than 1. Hence, the potential of failure of the structural member is low. That's all from me. Thank you.
Assalamualaikum and good morning. My name is Aida Ibrahim, matrix number B092-0103. So for a conclusion, at the end of this study, we learn how to evaluate actual structure and analyze the force member from the structure. Otherwise, from this study, we also can construct FBD from the structure and develop the equation which is vector equation of equilibrium and scalar equation of equilibrium. Lastly, we can analyze the maximum allowable force for the system and factor of safety used at the design. So that's all from us. Thank you very much.